Problem number 11. I want to rewrite each expression using sine instead of cosine. Now, when I look at part A and I see cosine squared x, I'm immediately reminded of the Pythagorean identity, because I know I can always make a substitution here. If I just take my Pythagorean identity, move that sine squared to the other side, I have cosine squared x equals 1 minus sine squared x. So I can come back to my original expression, and when I get to the cosine squared x, I can replace it with 1 minus sine squared x. All that's left is a little bit of cleanup here. I can distribute that 4, and then 4 and minus 7 are like terms, so 4 take away 7 is negative 3. I end up with negative 3 minus 4 sine squared x. It's an equivalent expression using sine instead of cosine. What about letter B, cosine fourth x? Well, this one requires a little bit of creativity. Cosine fourth x, I could think of that as cosine squared x being squared. In other words, cosine squared times another cosine squared would be cosine fourth x, 4 cosine x's in all. And now that I've done that, I can go ahead and make that same substitution. Cosine squared x is the same thing as 1 minus sine squared x. And so here is an equivalent expression using only the sine function. I think this is a perfectly fine answer. The other thing you could do, I suppose, is actually FOIL this thing out. You'd get 1 for the first. You'd get a couple of minus sine squared x's for the outer and inner, so minus 2 sine squared x. And then you'd get a sine fourth x at the end. And this would also be a perfectly acceptable answer. Problem number 12. The sine ratio for angle x is P. The sine ratio for angle 4x is Q. We want to find each of the things that are listed here. Looks like angle x is a pretty small angle. Letter A, sine squared x. That just means take the sine ratio and square it. Well, the sine ratio is P, so the answer here would just be P squared. We're not going to get number answers here. We're going to get answers in terms of P and or Q. How about letter B? I'm supposed to take the square root of 1 plus the sine ratio for angle 4x, all being squared. That ratio, according to the directions, is Q. So take the Q, square it, and again, I'm done. There's no way to simplify square roots of addition problems, and so I'm finished. Cosine x. Okay, I'm changing ratios now, so I think what I better do is draw myself a picture for angle x. X is between 0 and pi over 12. If you put the 180 in for pi, this works out to be 15 degrees. So this is a very small angle. Angle x is in the first quadrant. Here it is right here. The sine ratio for that angle is P, which I can think of as P over 1. So P over 1. For the cosine ratio, I'm going to need that missing side, that A side. A squared plus P squared equals 1 squared. In other words, A squared is 1 minus P squared. Don't worry about plus or minus in the first quadrant. The A comes out to be square root of 1 minus P squared, which means the cosine ratio for that angle is that square root, the adjacent, over the hypotenuse, which is 1. Of course, the 1 isn't doing anything, so the final answer here would just be that square root of 1 minus P squared. Letter D, I want to take 2. I want to multiply that by the cosine ratio being squared, and then I want to subtract 2. Well, cosine x is what we just found in the last problem, so I can substitute in that square root of 1 minus P squared. When you square a square root, it simply wipes it out, so squaring that is just going to leave me with 1 minus P squared. Let's see, I'll finish over here. I can distribute the 2 minus 2p squared, and then minus 2, and then the 2's go away. And so my final answer here is just negative 2p squared. Letter E involves angle 4x. Well, I think this is pretty similar. I just need a quick picture here. If x was 15 degrees, then 4x is 60 degrees. So this is still a first quadrant angle somewhere between 0 and 60 degrees. The sine ratio for angle 4x is q. Think of it as q over 1. I need to fill in that missing side. Well, the math is going to be exactly the same as what we did before. This is going to end up being square root of 1 minus q squared. And then the cosine ratio would be adjacent, that square root, divided by 1. Once again, the 1 isn't doing anything, and so this simply becomes the square root of 1 minus q squared. Another way that I could have done part C and part E would have been to use the Pythagorean identity. So for example, in part E, I could have said, I know that sine squared of 4x plus cosine squared of 4x is equal to 1. Well, sine 4x is q, so sine squared 4x is q squared. Here's what I want to find, cosine 4x, all being squared. Notice all I would have to do is move the q squared to the other side and then square root each side, and I would have cosine 4x equals this square root that we found down here. Letter F, how can I write an expression for angle x itself? Here's angle x in our picture. Well, the best I could do is I could write down a simple trig statement like sine x equals p. I know I'm in the first quadrant. I know specifically that angle x is somewhere between 0 and 15 degrees, so therefore angle x is just sine inverse of p. If I put the ratio p into the sine inverse function, I will get angle x. Lastly, sine of 3x, and the hint here is use a sum or difference identity. This one I have to be a little creative. I don't know anything about angle 3x. All I know is about angle x and 4x. Can I express 3x using the angles that I do know? And the answer is yeah, I can think of 3x as simply 4x minus x. And then I can pull up that identity, the difference angle identity for sine, and I can use that to rewrite this expression. Let's see, here it is right here. Sine of first minus second, sine first, cosine second, minus cosine first, sine second. And so let's fill that in. Sine first, cosine second, minus cosine first, sine second. And then we know all of these pieces from the work that we've done in this problem. Sine of 4x, we were given that at the beginning. It's equal to q. Cosine x, we figured that out in part C. It's square root of 1 minus p squared. Cosine 4x, that was part E. Square root of 1 minus q squared. And sine x, that was given to us at the very beginning of the problem, that was equal to p. I don't really have any simplifying I can do. My final answer would be q times this square root minus p times the other square root. Problem number 13, we have another complex fraction that we want to simplify. The LCD of the little fractions is sine x. So I'm going to multiply the top by sine x. I'm going to multiply the bottom by sine x. On the top, I have to distribute. I'll have sine x cosine x. For the second one, the sine x's will cancel, leaving me with cosine x. On the bottom, also the sine x's will cancel, leaving me with 2 cosine x. Can I go any further? The answer is yes, because on the top, I have a common factor of cosine x that I can pull to the front. So I pull out cosine x, leaving me with sine x plus 1. The bottom is already made up of 2 factors, the 2 and the cosine x. So now I have the cosine x's that divide out, meaning my final answer here is sine x plus 1 up top and then 2 on the bottom.